Good morning. My name is TIBAN. I am from 4BMMH. My title for my final year project is Experimental Investigation of the Sound Absorption Coefficient of Oil Palm Waste Fiber. This is the content of my final year project. First, introduction. The introduction mainly explains about the role of natural fiber in sound absorption coefficient. Second, problem statement, research objective, scope of study, literature review, methodology. It will explain about the preparation of fiber, sample preparation. The last one, measurement of sound absorption coefficient, result and discussion, and conclusion. Problem statement for the project is: first, role of natural fiber in acoustic field. Secondly, role of binder added with natural fiber in sound absorption. The objective of the project is to develop a sample-based oil palm waste fiber for sound absorption. This is mainly about creating or prepare a sample from oil palm waste to test in purpose of find out the sound absorption coefficient. Secondly, to find out the better sound absorption coefficient of natural fiber sample between with and without binder. So this one we prepare two type of sample with same density. With binder we add silicon as an extra material as a binder, and without binder we doesn't add any kind of binder or extra material. This is because we need to find out whether the sound absorption coefficient is for natural fiber with binder or without binder as the better sound absorption coefficient, and need to find out the role of binder in sound absorption coefficient. Scope of the study is: first, sound absorption efficiency of samples from oil palm waste fiber in specifically from petioles. Secondly, effect of thickness of natural fiber in acoustic field. Thirdly, presence of binder in sound absorption efficiency. For literature review part, we choose three keywords as a reference to find more details and information from the past researchers and journals. So first keyword is acoustic, secondly oil palm, third natural fiber. This literature review part, they mainly explain about what are the ways and parameters to increase the sound absorption coefficient. Mainly, they use binders such as lime and starch to increase the sound absorption coefficient. Some are they use different kind of size, thickness and density to increase the acoustic and sound absorption efficiency. Some they use some parameters like increasing volume of fiber to control the sound absorption. For natural fiber, the past researchers use different kind of natural fiber in the purpose of creating samples for acoustic field of sound absorption efficiency. Some they use waste tea to composite with some materials to find samples for mechanical properties for acoustic field. Some they use natural fiber as an acoustic material for its tensile strength and hardness. Some they use natural fiber for acoustic properties, like they use natural fiber like banana, coconut coir, hemp, jute and canna for their research purposes. Mainly, most of the researchers use binder to increase its sound absorption efficiency, or other researchers they use some kind of parameter like density and thickness to find out the sound absorption efficiency. So this is the methodology part. There are three parts in methodology chapter. First, the preparation of fiber from oil palm waste. First, we need to find oil palm waste from the garden or farm. We need to cut into two pieces in the purpose of extract fiber inside the petioles by using knife, like it's a mechanical rating process. So every step is from manually. We extract fiber, we wash wisely to remove the dirt from the fiber, and then dry under the sunlight for 3 to 4 days. It depends on the weather condition. We need to dry wisely to remove the moisture from the fiber, and then the fiber need to turn a small part, so it's easy to continue the further process like blender. In small parts, if we using small part, it's easy to blend. After blend, we need to remove the waste part of the dust, like dust from the fiber, to continue the second part. For this part, weighted oil palm fiber without binder, we use weighing scale digital to find out the mass of natural fiber. For without binder, we don't add any kind of binder or silicone. So every thickness from 1 cm thickness until 6 em thickness, we use weighing scale to find out the mass of natural fiber, and we need to insert the exact or desired mass of natural fiber in fiber slot. So this table is used to show the parameter or measurement or data of the samples without binder in fiber slot. There are 6 samples with different thickness from 1 cm thickness to 6 cm thickness. So the insertion of fiber is according to their thickness, but make sure the density for every thickness must be same. So we do some kind of calculation to make sure the density for every thickness must be same, almost same. You see the density for one sample thickness until 6 cm thickness sample are almost same. So this is the flow process for weighted oil palm fiber with binder. So this is the 3 process. First we measure the fiber slot mass, and then we insert the fiber into the fiber slot, and then we add the right amount of binder in the fiber slot. So these parameters all will use according to the table which made for their mass and the parameter of measurements. For the sample with binder in fiber slot, the process all are same. There are six type of sample with different thickness. This also same as the sample without binder in fiber slot. The density for every thickness must be same, even though their thickness all different, but we need to set the density same to find out its exact sound absorption coefficient of samples. This is the preparation of fiber slot and sample. First, we design the shape of fiber slot in SolidWorks with outer diameter 34.5 mm and inner diameter is 30 mm. It is constant with different thickness, and then the file save into STL format, and then it convert to Ultimaker Cura, and then we use PETG filament to print the fiber slot in 3D desktop computer. After the process was solved, we insert the fiber into the fiber slot according to their table mentioned, according to their mass mentioned in their table, and then we using weighing scale to find the exact mass, and then for With binder sample, we apply binder. Without binder, we don't need add any kind of binder. For evaluating sound absorption coefficient for fiber sample, first we need to set the impedance tube correctly, and then in AccuPro software we set job description, ambient pressure, ambient temperature according to the environmental reading, and then we insert the fiber sample into a impedance tube, and then we calibrate the impedance tube twice, and then we click start button, wait until the countdown until 200 average, and then we click calculate and then save the data in Excel graph. So we need to do this process for every fiber sample. So this is the result part of our final year project. The data fiber sample without binder is for 1 cm thickness is 0.55 at 4000 Hz, 2 cm thickness is 0.77 at 2500 Hz, 3 cm thickness is 0.81 at 2000 Hz, for 4 cm thickness is 0.97 at 1600 Hz, 5 cm thickness is 0.98 at 3150 Hz, 6 cm thickness is 0.99 at 1000 Hz. So this is the data fiber sample with binder. For 1 cm thickness is 0.82 at 3150 Hz, 2 cm thickness is 0.88 at 3150 Hz, 3 cm thickness is 0.96 at 2000 Hz and 2500 Hz, 4 cm thickness is 0.98 at 2000 Hz, 5 cm thickness is 0.99 at 1600 Hz, for 6 cm thickness is 1.04 at 1250 Hz. The comparison between the lowest and highest sound absorption of sample with and without binder. For without binder, for 1 cm thickness, the sound absorption is 0.55 at 4000 Hz, and the sound absorption for 1 cm thickness with binder is 0.82 at 3150 Hz. For the sound absorption for 6 cm thickness without binder is 0.99 at 1000 Hz, and sound absorption for 6 cm thickness with binder is 1.04 at 1250 Hz. So the sound absorption with 0.5 as considered as it as a good sound absorption. For this final year project or testing or experiment, all the fiber sample with or without binder, no matter with or without binder, all the sound absorption value is more than 0.5. So based on the result we obtain, the effect of thickness and mixture binder play the important role in sound absorption coefficient. We see when the thickness increases, the sound absorption also increases. Sample with binder also has the highest sound absorption coefficient compared to the sample without binder. So as we consider the sound absorption coefficient with and without binder, the sample with binder has the highest sound absorption coefficient, which is 1.04. For the recommendation, based on the data we obtained, the oil pump fiber sample has the capacity in acoustic field in future. This sample can be used as a sound absorber as an extra material in insulation or construction of building. Thank you.